Welcome to my channel. Today we're going to be talking about describing a scatter plot, association, and correlation. Okay, starting off we need to understand the idea of explanatory and response variables. What an explanatory variable does is it attempts to explain the response variable, and it is always graphed on the horizontal x-axis. Alright, let's just do an example. Heights of children are measured at 6 and then at 16, which is the explanatory variable and which is a response. So the explanatory variable, that in this situation would be age, since it's going to be graphed on the horizontal x, and age is continually going up, and it provokes the change in the response variable, which would then be height. Since with age, height will be the thing that's changing. When we're looking at association in scatter plots, there are three main types. The first is going to be a positive association. A positive association means that both variables, our x and our y, are increasing together. There's also negative association, where the increase in one variable indicates a decrease in the other. And lastly, there is no association. This is when the change in one variable isn't associated with the change in another. It often is pretty sporadic. When we're talking about scatter plots, we use specific language to describe them. We talk about direction. This is whether it's positive or negative. So positive is going up, and a negative direction would be going downwards. We talk about strength. Strength pretty much is just the closeness of the dots. If the dots are really tightly packed together, then we have a strong association. If the dots are more loose, then we may have a weak association. Then we also have to point out unusual features. And that includes outliers mostly. And lastly, when describing a scatter plot, we need to be wary of form. That's either if it is linear or nonlinear. Alright, let's do some examples. In this example, the direction would be positive. The form would be linear. The strength would be very strong as all the dots are fairly clustered together. And we don't have any unusual features to point out, so we won't mention that in this scenario. Let's do another example. In this one, the direction is positive, as you can see. The form seems to be going up in a linear direction. Therefore, we can say it's linear. The strength seems to be very strong and very clustered in this one area. So therefore, we can say it's very strong. And we need to point out unusual features. So we are going to say there's also an outlier right here. Let's talk about the correlation coefficient, and what that is really is a measure of strength and direction of a linear relationship between two quantitative variables, and the correlation is represented by R. Another thing to note is that you can have a very strong association, though a thing to note is that you can have a strong association but a weak correlation. Since correlation only works for those which are linear, association focuses more on how close the dots are. So if the dots are really close, but in somewhat of a parabolic shape, then it's going to have a very strong association, but a weak correlation. If R is positive, then we have a positive association. If r is negative, then we have a negative association. And when r equals 0, we have no association. Our values are between -1 and +1. -1 being a perfect negative association, and +1 being a perfect positive linear association. So the closer a r value is to 1 is the closer it is to being a perfect linear association. Same goes for -1. Another thing to note is that our r value is standardized, like the z-score, meaning that it's not affected by converting any units or changing the center or even scale. It has no effects on how the correlation comes out. Another important note is correlation does not equal causation. All this is saying is there is often an assumption that the explanatory variable caused the response variable, and this most of the time isn't true. Therefore, you have to be very critical when looking at the information you're given. Therefore, you have to use very specific language when coming to a conclusion and try not to make any assumptions. Another important note about scatter plots is straightening them. Straightening scatter plots. Since correlation, or our r value, is a measure of association for linear only, data can be re-expressed to determine the strength of the association between two variables. This is through either squaring, square rooting, or using log. Alright, let's do an example of association in scatter plots. The question asks, make a scatter plot of the femur and humerus lengths from dinosaurs. Determine if these 5 specimens are of the same species. So we're given the femur lengths and the humerus lengths. So what we're going to do is we're going to put this information in a list on our graphing calculator. To do that, we're just going to press Stat and go to Edit and create a list. As you can see, I already went ahead and put in all the data into 2 lists. The next thing we're going to do is second function stat plot, plot 1. We're going to press on, go to scatter plot, and for x list, we're going to do list 1, y list, list 2. Then we are going to go to zoom. From zoom, we are going to scroll down to 9, which is zoom stat. If I did it correctly, then it should look something like this. What does this tell us about these specimens being from the same species? Well, as we can see, there is a linear relationship, and the association between each of our points is decently strong. Therefore, we can say yes, there is an association between the femur and humerus lengths from these 5 specimens, alluding that they can be from the same species. Thanks for watching my video. If you want to see more math tips, please like or subscribe. Anyways, I'll see you later.